Hi, my name is Callum Roger. This is my submission for Design 105. So I'm just going to click play game. So essentially my game is called GunShipy, and all it is just a standard sort of retro-like asteroid shooter. So I'm just defined on the x-axis as like a rail system, and we can shoot laser beams whilst rotating to destroy asteroids. My player does have 10 health points, so if we were to unfortunately be struck by asteroids, like I'll just do here, we will die and we'll just get a game over screen. I'll now take you over to the code and I'll run you through that. So for main menu, I just started with a standard public void called play game. This is just so when you press the actual play game button, the scene manager loads the active scene with index number of +1. So we press the play button and GunShipy's main scene will start and the game begins. Same for if we press the quit button, the application will just simply quit. So for player controls, I set up a few public float variables to begin with, firstly being speed, rotation speed, and also a gunship boundary, which I'll come on to in just a second. So the first sort of lines of code in the void update function, which is also checking frame by frame of the game when it's running, is finding the actual input buttons. In this case I used the axis inputs that you can find also in Unity's inputs. In this case I used the horizontal axis being the either A and D keys or the left and right keys. In this case for the game I'm just using A and D to move left and right. Doing so obviously will then multiply by the speed float that I created by time itself, delta time, and that will set the speed accordingly. As far as the actual ship moving left and right, I had to sort of bound it to the actual screen itself. So I used the orthographic size of the camera, or the main camera in Unity, to make sure my ship didn't obviously just fly off left or right of the screen. In this case, we're looking at the position X defined by the input, and then going from there, if the position plus a gunship boundary, if that's greater than the actual camera's orthographic size, then the position will be before the boundary of the camera minus its boundary, so the ship won't just sort of clip off the edge, it'll stay there. And same for the other side of the camera boundary as well, on the negative axis. As for rotation on the z-axis, I used quaternion rotation. So in this case, all I'm looking for is vertical input, again using axis inputs, and this is either the WS keys or the up and down arrow keys, times my rotation speed, which I defined using a float as well, and time.delta time, and that allows me to rotate on the z-axis. The player damage script starts off with a public float, so I could change this within Unity, just called health simply, and I've assigned it just with number 10, so the player health is set to 10 lives. I then also used on-collision enter 2D, so in this case, when the asteroid hits the gunship, an asteroid is just destroyed, but the player has also deducted 1 health point. So here we've got an if statement simply saying if health is equal to or less than 0, then the die function is called, and the game over function is also called. So here I have void die, which is simply just destroy the game object, being the player ship is destroyed, and void game over, which is again using the scene manager to load in an active build index of +1, and that is our game over screen that we see at the end. So for the gunship actually shooting, in this case I made a game object here called laser beam prefab. In this case what we're looking for is when we're finding the input, in this case fire 1, which is inside Unity's inputs. Fire 1 is just a left mouse click, so we're looking for when that button is actually being pressed, then we'll know we can shoot. As so the bullet would actually take health from the player, an offset was required, as the actual laser beam bullet would be spawning from the center of the gunship's sprite. Obviously every time I did this, health would be deducted from me, and then eventually the ship would die after just only shooting 10 rounds. So I made a bullet offset of just 0.5 on the y-axis of the sprite, and that means it just shoots just above it. I then also applied this offset as well to the rotation, the transform dot rotation, just so obviously when we're rotating we still wouldn't be taking any health off the gunship. And then lastly I had to instantiate the laser beam bullet simply by just calling the actual laser beam prefab that I made in Unity with its transform rotation and the offset and the rotation as well. Bullet travel started with a max speed of 5, which again I made public so I could change this on the fly within Unity when testing. Simply, the bullet velocity was made using a vector 3. So in this case, I had vector 3 position equal to transform dot position. Using that, I was able to then declare using a new vector 3 within vector 3 velocity to define its x, y, and z values. So here I've just got my max speed, which I defined as 5 times time.delta time. Using that, I was able to then just do a position equals position plus its transform rotation times velocity, simply so the velocity can be carried also when rotating, and then transform rotation is just equals position. So our laser trigger, our laser bullet beam trigger in this case, we're simply using just a void on collision enter 2D. In this case I called this collision call. So we're using an if statement here that is simply if the laser prefab hits any game objects with the tag enemy, in this case all the asteroids in my game are tagged enemy, then they're just simply destroyed. As you can see, destroy, call, and then the game object itself. It is important to not have game objects infinitely being created and basically nowhere to go other than to venture out into the void outside the camera view. It's important that I had to create like a cleanup or a self-destruct, as people sometimes call it. In this case I just called it laser beam cleanup, and all it's simply doing is I'm just creating a float timer with a value of 2 seconds. So simply, if the laser beams that I shoot from my gunship don't hit any asteroids, after 2 seconds they'll just self-destruct or be destroyed. So in this case I'm using an if statement again, and as for my timer I'm just using time.delta time. So in this case, if the timer is less than or equal to 0, then the game object, in this case being the laser beam, will just be destroyed. This is my asteroid controller. So simply I've just got 2 floats, x angle, y speed. In this case I'm just grabbing my rigid body 2D, my asteroids, and then using a random range to define a number for the x angle and the same for the y speed. After 10 seconds the asteroids will be destroyed if they're not damaged in any way. And then simply just in the update function all I'm doing is just taking my rigid bodies and applying my angles and speeds. The spawn manager's job is to just take my 4 asteroid sprites and essentially randomize them for spawning in. So my random number is just an integer, and I have a float spawn timer which has got a value of 1 just now. All that's simply happening is the spawn timer is being kept up to date with time.delta time. Essentially, if my spawn timer is greater than the value of 200, then the spawn position will take a random range of between -4.5 and 4.5 for the x-axis, take my game object itself, which is my asteroid, and essentially instantiate that so it can clone it as many times as possible. Once that's done, the spawn timer will return to 0. To improve this project I would simply just add in an actual score system and also a health bar so the player could visualize exactly what is going on in the game. Unfortunately I didn't have the time near the end as well as the know-how to really implement this, but that's something I would definitely do for the future. Thank you for watching, and I hope you enjoyed it.